The purpose of this project was to do simulations of neutron spin gymnastics for the polarization and transmission measurement of the nEDM experiment at SNS. The purpose of the nEDM at SNS experiment is to search for the neutron electric dipole moment using ultra-cold neutrons. If there is an electric field, the Larmor precession frequency of the neutrons will change. The goal of the PT measurement is to measure the polarization loss and transmission efficiency of the neutrons and to see if neutron depolarization can be caused by any magnetic field non-uniformities. This project seeks to find the spin precession of the neutrons by simulating the magnetic fields due to different parts of the apparatus, such as the supermirror polarizer and the spin flipper. The spin precessions of the neutrons were calculated by using Runge-Kutta code in Python. The code allows the x, y, and z components of a magnetic field to be inputted into the block equations, as shown on the poster, and then solves the block equations for the spin. The spin is then graphed versus time to show the spin precession. On the poster, there are two examples of this code being implemented. The first shows a simple spin flipper. The magnetic field starts in the y direction, then changes to the x direction, then back to the y direction, while the field in the z direction stays at 0. As you can see in the spin precession graph, the spin starts out completely in the positive y direction and ends completely in the negative y direction. Thus, the spin has been flipped. While this is not an accurate picture of the spin flipper used in the apparatus for the experiment, it shows how the code can be used to simulate different magnetic fields. The other graphs represent the supermirror polarizer from the apparatus. The magnetic fields were given from experimental data and then fitted with an equation in order to be put into the code. The equation was a piecewise function made up of an initial horizontal component and then an exponential component. The magnetic field starts out mostly in the y direction. However, while it is difficult to see on this graph because of the scale, there's a small constant x component. The y component of the field then goes to 0, so all that is left is the small x component. This means that on the spin precession graph, the spin starts in the y direction but later goes to the x direction. Additionally, though it is difficult to see on these graphs, the spins in each direction are oscillating. Currently, the only magnetic fields from the apparatus being simulated are the ones from the supermirror polarizer. In the future, other magnetic fields, such as the one from the spin flipper, will need to be added to better simulate the spins of the neutrons in this experiment.